So next we will see another example. So here the complex is anionic in nature, and if you see the central metal atom, it is nickel, whose atomic number is 28. So here if you see the ligand, the nature of the ligand is weak field ligand. So it won't promote any electron pairing or spin pairing in inner orbitals. So obviously it will form a high spin complex or spin free complex or outer orbital complex. So hybridization will happen in outer orbitals of the central metal atom, not the n-1d orbital. That's what it means. So next step is oxidation number. So the oxidation state of nickel, here we are seeing the +2 oxidation state, and the ligand is chloride ion. So the name of the ligand will become chlorido while writing the IUPAC name of the complex. So if you see the IUPAC name, it will be tetrachlorido nickelate 2. So tetrachlorido because 4 chloride ions are there linked to central metal atom in the coordination sphere. And if you say nickelate, because this is an anion complex, the central metal atom name will end with 8, and the oxidation state is expressed in Roman letter, that is +2 in Roman letters in parenthesis. So that's what about the name of the complex. So if you see the description of this coordination compound through valency bond theory, first we have to see the electronic configuration of normal nickel atom. So whose atomic number is Z is equal to 28. So it will be, if you simplify the configuration and write with respect to nearest noble gas configuration, it will be AR 4s2 3d8 4p0 4d0. So for our convenience, so we are rewriting that it will be like AR 3d8 4s2 4p0 4d0. So then if you expand the configuration in the form of orbitals, so nickel has to lose 2 electrons to form the nickel cation. So nickel cation will have a configuration of 3d8 but 4s0 4p0 4d0. So being weak field ligand, chloride ion cannot promote the inner orbital spin pairing or electron pairing, you can say. So what will happen in n-1d inner orbital pairing, electron pairing will not happen. So that outer orbitals present in the valence shell like ns, np and nd has the chance to participate in the hybridization. But here we require only 4 hybrid orbitals to accommodate 4 linkages through the electrons of the chloride ions. So that's why we require only 4 hybrid orbitals. So outer orbitals, empty orbitals like 1 4s and 3 4p orbitals will participate in hybridization to form 4 equal energy containing sp3 hybrid orbitals. So here in the central metal atom, so there are 4 empty hybrid orbitals which can receive 4 pair of electrons from 4 chloride atoms, and its 3D configuration is 3D orbitals are having 2 unpaired electrons. This is the state of the complex. So if you try to see the parameters of the nature of the covalent compound, so we have found the hybridization is sp3. So sp3, because of sp3, geometry will be tetrahedral. The entire complex will form the tetrahedral geometry, and because of the unpaired electrons present in the inner d orbital, n-1d, that is 3d, magnetic nature will be paramagnetic, right? Then it forms the outer orbital complex or spin free complex, we will say.